In 10% Human, Alana Collin discusses research showing that certain microbes can alter the behavior of their hosts to improve their own survival and spread. The central example is Toxoplasma gondii, a microscopic parasite. The book describes how infected rodents lose their natural fear of cats, and may even become attracted to cat urine. This makes them more likely to be eaten by cats, which is necessary for the parasite's life cycle. The book then asks a provocative question: if microbes can alter animal behavior so dramatically, could they subtly influence human behavior too? 2. What is firmly established science? The following points are not controversial in mainstream biology. In animals, Toxoplasma gondii clearly alters rodent behavior. This is one of the strongest examples of a parasite manipulating a host's nervous system for its own benefit. In humans, it is well established that a large portion of humans carry latent Toxoplasma infection. The parasite can form cysts in the human brain. Severe disease can occur in immune-suppressed people and in congenital infection. 3. Where the science becomes uncertain, the more speculative area is behavioral influence in humans. There are associations reported in studies between latent Toxoplasma infection and increased risk-taking behavior, slightly higher rates of traffic accidents, some associations with schizophrenia-like symptoms, changes in attention and reaction time. However, these are correlations, not definitive proof of causation. Effect sizes are typically small. Many confounding factors are difficult to control. Mainstream science position: it is plausible that latent infection might subtly influence behavior, but this is not proven in a strong or deterministic way. 4. The free will question: how science actually views it. The book uses free will poetically rather than philosophically. What science would say carefully: microbes do not control your decisions in a puppet master sense. But biological systems already influence behavior heavily. Hormones, neurotransmitters, immune signaling, inflammation, the gut-brain axis. Microbes can affect neurotransmitter production, for example, serotonin precursors, inflammatory brain signaling, stress responses, via the vagus nerve. So the realistic position is, microbes may bias mood, impulse, and stress reactivity, which can shift the starting position from which decisions are made, but not override conscious agency. 5. What scientists are more confident about? Less controversial than mind control. The gut microbiome influences anxiety-like behavior, shown strongly in animal models. Stress reactivity, mood regulation pathways. This influence is subtle and modulatory, not controlling. 6. How modern science currently frames this idea. A careful scientific wording would be: microbes can influence host neurochemistry and immune brain signaling. This can subtly shape emotional and behavioral tendencies. There is no strong evidence that microbes can override human free will. 7. The intellectually honest bottom line: in plain terms, microbes do influence brain and behavior in animals and likely have subtle effects in humans. Toxoplasma is a real and fascinating example of biological manipulation. The idea that microbes control human free will is speculative and overstated in popular writing. A more accurate view is that microbes can nudge, not commandeer, human behavior. 8. Why the author included this? The purpose of this section of the book is not to claim people are puppets of microbes, but to make a deeper point: humans are biological ecosystems, not isolated individuals. Our thoughts and behaviors emerge from our neurons, our hormones, our immune system, our microbes.